Chapter 1.2.3 Controllers. A control loop in robotics and automation regulates the state of a system through continuous feedback. An example is a thermostat in a room where the desired state is set by the user, and the current state is the room temperature. Controllers in Kubernetes operate similarly by watching the cluster state and making changes to move it closer to the desired state. Controller pattern. A controller in Kubernetes tracks at least one resource type, such as a job. The controller ensures that the current state of the resource moves closer to the desired state specified in the resource's spec field. The job controller manages pods to carry out tasks and communicates with the cluster API server to create or remove pods as needed. Some controllers, like job, interact directly with the cluster API server, while others may require communication with external systems to make changes outside the cluster, such as adding new nodes. Controllers update the objects that configure them and report the current state back to the API server. They work with other components in the control plane to ensure that the desired state is achieved. In some cases, multiple controllers may work together to bring about the desired state, much like a thermostat turning on a heater when a room is too cold. Overall, controllers in Kubernetes play a crucial role in managing resources, ensuring that the desired state is achieved, and interacting with external systems as needed to maintain the cluster's functionality. By extending Kubernetes to work with various services, controllers enable the seamless operation and automation of tasks within Kubernetes clusters. Desired versus current state. Kubernetes is designed to handle constant change in a cloud-native environment. Clusters are always changing due to ongoing work and automated control loops that fix failures. This constant evolution means that a Kubernetes cluster may never reach a stable state. As long as the controllers are operational and making necessary adjustments, the overall stability of the cluster is not a primary concern. Kubernetes utilizes multiple controllers to manage different aspects of cluster state, with each controller focusing on specific resources to achieve desired states. For example, the job controller tracks job objects and pod objects to run jobs and monitor completion. Having separate controllers for different tasks prevents a single point of failure and allows for easier troubleshooting. Multiple controllers can create or update the same type of object, but Kubernetes ensures that each controller only interacts with resources associated with its controlling resource. This allows for efficient management and organization of resources within a Kubernetes cluster. Ways of running controllers. Kubernetes has built-in controllers like the deployment controller and job controller, which provide core functionalities. These controllers run inside the Kube Controller Manager and ensure that the control plane remains resilient. In case of failure, another part of the control plane takes over the work. However, Kubernetes also allows for running controllers outside the control plane, either as pods or externally, depending on the specific requirements of the controller.